name is Steve Poole. I work for IBM. I'm a developer advocate for Java runtimes, which means I get to talk to you about all the cool stuff that happens in Java, and as you'll see, even the different spaces like Eclipse and stuff like that. And my colleague, Andy, who will stand it well, we're going to have fun because his voice is going. So we're going to do, yeah. So Andy is developer advocate for a thing that we're going to show at the end called Eclipse Codewind. And this talk is going to talk to you, thank you for coming. I'm sure you're intrigued to understand what's going to happen to your IDE. So we're going to take you on a little journey and talk about reality today for developers and how that's going to affect the way that you develop in the future. And it's a pretty high-level view, but we do promise, if we can get some tech, that we'll give you some demos of at least one set of tech in this space. So I'm just pointing this out. This is where we work in the UK. Oh, actually, we don't work there. We work in an old building about here, right? But that's great. Okay, so I think I said about what we're going to talk about. So why cloud? Why are we here? Because cloud. It's what we've always wanted. Okay. Sorry, more people keep coming in. Just sit anywhere. It's a chat. We are here today. In fact, you're probably here at Devnexus. A lot of it is driven by this thing, cloud. Where we're going with cloud, how we're going to get there. But it isn't really cloud that we talk about. It's containers. It's all the story today is containers. And we're going to talk about why that is a challenge for us. Right? Containers are great because we can put them all together and build great solutions that we've never had before. And that's a really good promise. And basically, as long as the answer is container, put it in a container, we're done, right? A lot of people think that. I'm just going to put it in a container and it's tick, right? And as we're going to show you, that's not actually as good as you might think. The reason that we picked containers as the way forward is because of two little words, immutability and repeatability. The idea is that you can put something in a container and it will behave the same way under all circumstances, and you can just build it and scale systems. It's one of the reasons that we're doing containers because we think we can build larger, more complicated systems. And as a result, we're starting to take away those long-running old systems that are a bit heavyweight. They're still really important, but we're trying to modernize them. So we're going away from big things to replace them with short-lived things that are, wow, loads. In fact, you think how many mice you need to replace an elephant? Quite a few. Okay. And when we first started with containers and we were on this journey, we thought it was easy. Everybody went, yes, great, put source code in Git, compile it locally, have a Docker file to create myself a container, shove it up to the Docker registry, and I'm done. End of story. Have to do nothing else. How many people here are Java programmers? Cool. How many of you use containers? Okay. And how many of you deployed to Kubernetes? Oh, more in this room than usual. That's good. Okay. It's turned out that this is not true. And that actually those things of that wonderful meme that you may have said where works fine for development, it's an ops problem now. It's not like that. It really isn't. Okay. Let's look at what you have to do. So as a developer in containers, it's quite tough, right? So there's a whole bunch of choices you have to make. So as a developer, this is not even a container story, this is a developer story. First off, pick your platform. What's your runtime? What do you want to do, Linux or Windows or Mac or whatever? Okay, and then you pick your version of Java that you care about, and you have choices there. And then you have to decide what frameworks you want to pick. And then you have to choose a build cycle, how you're going to build that, which means, are you going to use Maven or Gradle or something else? Okay, and are you going to put it in Git or are you going to use something else? These are all choices you make, right? And then you add in things like what IDE you want to use. So let's do that. Who here does not use IntelliJ? Okay, because if I ask the other way around, it's just silly. Anybody here use Eclipse? Okay. Or VS Code? Okay. It's a tiny. Sorry. And the rest of you use IntelliJ, don't you? Yes, of course. Right. So you've made those choices. And then you have a bunch of testing tools that you have to put in there and test frameworks and databases and mocking libraries, and maybe you're going to plug some plugins in the IDE, right? Okay, and that's just now. And then we go, okay, and now you've got to add, that's your local life cycle. And then you would take all that, ta-da, go on, aha. And then we add in the CI/CD system. So you're checking your code that you've built lovingly locally into Git, and then Jenkins goes and does it again. And the takeaway to remember is what Jenkins does, the way it builds things, is different from what you do on your desk for a whole bunch of reasons. Okay? And that's all just to get an old style jar or something or a WAR file onto a server. And now we add in cloud, and cloud says, oh yeah, not just one framework choice, 2, 3, 4, 5, 10. And not just one platform, one runtime, because you're now building services using a whole bunch of different runtimes, because. Right, so you add all that in, and then you take whatever you do on your desktop, which you do it locally, and now you've got to build a container. So you're going to take stuff that you do locally. So you're doing local development, boom, 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 compile, save, lovely. And then what do? Then you run a build. So you might do a Maven build to prove it works completely. And then maybe you'll then run something to create a Docker container, or you mix and match. But you have all these different things. Now, what's happening is these are all opinions on what your code should do and how it should behave, all the way through this story, okay? And Jenkins has the same problem because your build systems mimic what you do. So they do the full builds, and then they might build a container, and then you're going to do it at different stages. Why? Because what you spit out in the container in your build process, what you allow in it, where you base it from, changes. You have thinner containers for production. You have development stuff you don't want in production containers. So you have all this extra. Right? And all of this to produce that Docker image, okay, which we're saying, hey, it's immutable. Okay, the question we have, and everybody is hitting this problem, is that this is really lovely, but what the developer thought they wanted to achieve and what actually spits out in production doesn't necessarily match. Okay? So to put some boxes around it, what we're seeing is, whereas we used to have one or two opinions about what was going on, and opinions in terms of what is correct behavior. So you have what the IDE thinks, right? You're in IntelliJ and you do Control S. Your IDE builds your code. There's a thing called an inner loop, build your code, great. And then you may do a full build, so that's the second opinion. And then you may do it in a container, it's the third opinion. Then you give it to the CI system, and it does another one, and it does another one, and then you do a production version, and then you run something, right? Every single one of these stages is an opportunity for different behavior. Sometimes it's deliberate, and sometimes it's just incidental, right? And we do all this, all these extra texts and things, because we don't know whether we can trust what you do on your desktop, right? Which is the irony in all of this. The irony is that we're supposed to be creating systems that will allow you to do your job more easily and give you certainty that the code that you do on your desktop matches the environment and the behavior of your build processes and your production system. But in fact, what we're beginning to see is it's actually the other way around. So what you hear is, we'll see how many of you have this feeling. Right, so you have a common cell. This is your system. There's your local development on your laptop, and then there's your CI system, and then your production system. And commonly, what you build and test here doesn't match what gets built on the build systems, and doesn't match what runs in production, because you've got a different production. Your runtime environment is different from the big fat kube, right? So what runs there is difficult to test, because you can't reproduce this big complicated system in your build environment. Okay, and it's certainly impossible, almost impossible, to do it locally. Okay, so the consequence is, when you talk to people, is they go, actually, that container that I created was not what I expected and was a bit rubbish. Okay, and when it goes wrong, debugging it is horrible. Yeah, you all know what it's like if you've done any sort of container development, trying to debug it, it's like trying to debug an iOS app through a letterbox. It's just impossible, right? Okay. So, and it gets more important. Part of the evolution has been to free you up and give you more choices. So where we thought we were going to have one architecture, this evolution of things from the old monolith to a monolith in a box, i.e. lift and shift, to microservices, to serverless or micro functions, all that running on the cloud, yeah. We're using not just one, we're using all of them with different runtimes and different languages. Welcome to your new life, right? And this is what everybody is struggling with. But it's cloud. It's only a little bit of rain. Containerization is turning out to be much more disruptive than anybody thought because of these consequences. It's very good to put a thing in a box, but if you can't trust it, then you have to keep rebuilding your box and you have to keep going through it, right? It's not only constructive at a development point of view, it's disruptive about how we produce JVMs and what runtimes do and all that sort of stuff, okay? But from this point of view, disruptive stuff from a development processes point of view is, wow, let's look at the complexity. So to get these choices running, the most obvious thing that we need now is a whack and great shipyard to hold all those containers, because that's what you're doing. And that's called Kubernetes. Okay, who loves Kubernetes? Wow, leave the room. No, really? Okay, I like it, but it's just enormous. We'll talk about that in a sec. So to manage Kubernetes effectively, you need tools, because this is not your new reality, isn't it? You have lots and lots of containers running in servers on your kube. In fact, if you're not running at scale, then it's questionable why you're using it in the first place. But there we go. Right. So the first thing you have to say is, what tools are around for you to make your life better? What tools exist to manage Kubernetes that you need to get your head around? Because that tells you how your development experience is going to change. Yeah, well, when you learn something new, at least what I do is I go to Google and I go, what are the top tools I should learn? And normally when you do that, it will come back and say, I don't know, top 3 tools or top 5 tools. So when I started doing Kubernetes learning, I did that, and it said, here are the top 50 useful to Kubernetes tools. And I went through that list, okay? And I went, oh, okay, this is all reasonable. What you have to understand is that the whole of this journey is nowhere fully baked. We are fully exploring this. You saw some great stuff at the keynote with Ray and Bird talking about what they could do, and that's fabulous. But we all know that the journey is nowhere near complete because we have this level of complexity that you have to deal with. So you have to deal with tools like this. This is the CNCF, so the Cloud Native Computing Function, which is a foundation, which I encourage you to go visit. We've got some links at the end. The thing about this is, these are the tools that are out there that people are creating for all the different parts of the story, right? And the CNCF is trying to corral this, but believe me, there's a lot still coming down the road that you may have to deal with. And closer to home, the way that you build things is changing because of containers. So if you've got a cloud service, then you're running at high availability, then you soon realize that having a Jenkins server in the middle, whose job is to build and deploy things, having a single server suddenly becomes a vulnerability. You don't want it to go down. So we are moving very rapidly from structures like this, where you have Jenkins server and you have jobs and flows through it, which is very nice to easy to understand. We've all set those sorts of things up. We're now into this mode, using things like Jenkins X and Tekton. So now we're talking about pipelines. So that means every container that you produce is probably going to have, or will need to have, its own pipeline definition, which is like a path through a Jenkins server, written in YAML, of course, but the idea is that reduces the chance of your server failing because you don't have a build server, you have a build cluster, Kubernetes based, that you use Tekton to do the steps. Okay. So what we're seeing is that the new world really is these three things: Kubernetes for the base platform, Docker containers, and even Docker containers are evolving, but it's a separate talk, and Tekton in the middle as the pipeline glue. There are other things built on top of this, Knative and things like this, but that just adds to the complexity. It's all about containers. Operating systems themselves are becoming containerized. So you will find that your life there is going to change too. Everything about the way that we thought containers was going to help us is true, but we're beginning to learn the consequences. And the consequences are that 80% of you have containerized solutions. Doesn't mean you're dealing with Kubernetes. Lots of people use them just as a delivery vehicle to other servers, right? And what we're learning is that actually many of the people who we would think will be picking up this complexity, the ops teams in the sort of DevOps cycle, aren't. Okay. Famous pseudo-Chinese saying, because I think it may have been British or something. Anyway, may you live in interesting times. Okay, we've all heard of those. Do you want to see what the container version is? Here's the Kubernetes version of may you live in interesting times. The container space is really exciting, and it's hard to keep up with the amount of new and exciting projects that appear every month. So please don't think this journey is finished. Right? Bit more wet than we realized. So the question is, what can we do about it? Right? What's changing? So we can't just stop and start again, so we're not going to do that. What we're actually giving you is some monstrous tools. This is a jet-powered fire engine. Its job originally was to put out nuclear fires, but it's used to put out oil fires. So it's two jet engines, and it just goes, spurts water. And we're building tools like that because it's what we have to do, right? So now we're to, how do we do this? How do we take this type of stuff, which breaks into a whole range of the old style of doing business, long-running applications to tiny services and lots, and it's just two completely different planes of architecture. What are we doing? What are we exploring to help you create and deploy this stuff? We're doing everything we possibly can in all different ways. If it was transport, we're trying every single transport mode you can think of, including jet-powered backpacks, submarines, you know it. Right? It's everywhere, and it's leaking into your life. Right? It's just changing. I encourage you to start Googling about tools, and you will begin to realize that life is complicated. So, why do we think, what's the point of having this conversation? What can we do about it? And this is a development experience talk, right? So, what we could do is take this much harder life that we've got, right, and do some things. So question one is, what could we do to give you access to an environment that matches this far end? What can we do to give you something there that matches this end? And what can we do to make sure that you can still deliver code at a high speed? Okay. How do we merge all these different parts of the puzzle? Well, we've got to overcome a few things we've talked about. The obvious thing is the environments are completely different. What you have on your laptop and what you have running on a kube cluster is completely different. That's true. The tooling space is completely mismatched. The scale is completely mismatched. Anybody tried to run 1,000 containers on their laptop? Not a good thing to do, but sometimes that's what you've got to do to get involved in this. Right? This isn't new. I don't want you to think that we're saying it's a new problem. It's just the same problem that we've always had. It's just blown up. Right? Which is why many people feel very lost. I don't know how many of you have looked at the tool space and go, I don't know what to do. I know where I want to get to. I don't know what choices to make. Many people feel like that. I'm not going to try and solve all those problems. And as I said, it's turning out as a development community, quite often the DevOps relationship is turning into they worry about Kubernetes and your problem is to deal with everything else. Okay? So, what can we do? So where is this all leading to? It's leading to a few thoughts about how we actually build things and what we can do. So this is really early days, right? And we're going to show you, we're going to give you a demo of one place that the Eclipse community are looking at, but it's early days. But the point is to make you start thinking about how and why we're doing this and what you could do next. So what could we do? Well, we could do this. We could take Kubernetes and run it on your local desktop. Who wants to run Kubernetes on their laptop? Excellent answer, right? You know, if you want to heat your room, run Kubernetes because the fan just comes on. So we're not going to do that, are we? Okay. What we could do, though, is take the development environment that you've got, this process, put a box around it, put it in a container, okay, and then move the container over here. So now we're starting to explore what can we do to take the tools that you use locally and put them in a container themselves and then start to put them in places. And I'll talk a little bit more about what that looks like, and then we'll do this. Right. So, number one we could think of is to take the tooling that you use locally and make it better fitting the whole process. Okay. And you can do that already to a degree. So like VS Code has remote editing capabilities. As a developer, you can do things locally, or you think you're doing it locally, but actually everything is happening somewhere else on a remote server. That gets you a bit closer to being in the same environment. Okay, and the other thing you can do is you can put the whole of the IDE into the cloud. So this is where we go, I'm not giving up IntelliJ, and I'm not exactly saying that. But one of the things we're exploring is, can we put the whole of the development experience that you would normally run on your desk in the cloud, but still give you access to it via a browser, right? And that means if we do that, that you don't need to worry about your local environment having mismatches or even having Docker, because you're just doing things in the browser. And as long as the experience matches what you get now, why would that be a problem? Right. And that's what Eclipse gives you. So I encourage you to go have a look at that if you're interested in these. There's a bunch of reasons why this is useful beyond helping reduce the complexity, right? But we'll talk about this right at the end. But I want you to know, we are exploring what can we do with the way that you develop code to help you reduce these challenges. Okay. The other thing is to take the build environment, the build tools that you use, and put them in a container. So you have a container that you produce. Why don't we take all the tools that you need to build that and put that in a container? Because if you do that, then you run that locally. Right? So you can actually have the same build experience that you need running locally. Same build tools in a container running everywhere. Okay. And that's what Eclipse CodeWin looks at, and that's what Andy will talk about. So I just put some, so it's a whirlwind thing, but I want to show you what we're thinking about. So we have all these different places where different opinions are happening and different environments are needed, and we're exploring what we can do to bring them together. So we can take the first two, right, and we can join those together, and we can start saying not what the IDE thinks, i.e. what your Control S thinks, or what your Maven build thinks. Now we can have, why don't we have something called dev mode? Who went to the keynote and saw Burr and, okay, so Cool. I think most of them go to that. Quarkus gives you that capability. Quarkus has a dev mode. You just put it does all the compilation and the packaging for you. Right? It's your IDE is no longer doing it. So there's not, your Control S is triggering it to do the work, not have your IDE do the compilation. That's the first steps of us moving away from having the IDE have all the smarts, and we're trying to separate that smarts into different tools. So Quarkus is demonstrating that that's a really useful activity because you can get the round tripping so fast. Okay. Well, what else? Well, actually, you can extend dev mode and you can put it into the build tools. So you've now got the build tools in the container. So like Quarkus does now, but you could extend that and make that configurable so you can have your own build tools in the container. Okay. And the final option we've got, oh, my animation didn't work. Okay, so my animation, oh no, sorry, I take it back. I won't say it has. The other thing is, if you have your build tools in a container, and it builds in a container, then it's got the same experience, the same process everywhere. So you don't have to have lots of boxes that do things differently. You just go, I have a containerized build process, right? All the tools I need to build things are in a container that produces an image, right? And then finally, we can take all these boxes of all opinions and replace them with just one and call that containerized development. And that's where the Cloud IDE question starts to pop its head. If I give you a development environment that gives you peace of mind and you're able to do everything that you need and that you're comfortable as a developer that the stuff that you build now is much closer to the experience of production, that you can test it easier because you're in a larger environment, so you have better integration with the testing tools, the performance tools, how much would you be willing to give up on your IDE? So we think there are two ways that this is going to go. One is we're going to have this middle line, which is the IDE, you use the IDE as you're using it now, but actually all the stuff that's taking place within your IDE, the heavy lifting, where the source code even, isn't going to be on your laptop. Your IDE is your tool to interact with it, but everything else, like the Quarkus thing, is going to be in the cloud, and you're going to connect to it remotely. Or finally, just as we've seen with, as you'll see with Eclipse J, we may move the whole IDE into the cloud and give you browser access. Now, believe me, we're not saying it's a Mickey Mouse thing. If you look at what the technology is giving you now, and Andy will demo it, it's good quality. We're getting, it does the things you'd expect it to do. So that's sort of a whirlwind tour of where stuff is going. It's driven by the container world. We're looking at this as a reaction. It is really early days. We're not saying you can go off and buy a whole bunch of solutions right now, but we thought it would be good to just tell people that stuff is changing, and don't be surprised if you start to see this stuff appearing in your IDEs. Right. Andy, do you want to come off and do a cool demo? Or a demo? Of course it's cool. You need this one. Grab that. You need the magic recorder.
Hi there, can everyone hear me? Thanks Steve. My name's Andy Watson. As Steve kindly said earlier, I'm a developer advocate working at IBM in the UK in Hursley. And I've been working on a Eclipse project called Eclipse Codewind, which let me share my screen. Sorry, one moment. So as Steve mentioned, there's lots of different tools available to people these days when you're trying to look at working with in your IDE and looking at building containers, moving to Kubernetes. And some of these are actually, as Steve mentioned, will be provided by independent vendors, work on specific plugins, ticket clouds. And what we're trying to do with the Eclipse Codewind project is try and create a plugin which is actually IDE agnostic and cloud agnostic. Taking some of the logic that you would normally expect to be in the plugin, but actually put it into a container itself and just provide access to it via your favorite IDE. So primarily, we're looking to extend the IDEs, bring cloud native support easier, trying to make it so that actually as developers, you don't need to know too much about containers themselves. You don't have to learn Docker, Docker Compose, Kubernetes command line, make it a much easier entry point to be able to do what you need to do all from within the comfort of your favorite IDE and without having to break out into command line to do some of the more repetitive aspects of cloud native development. So again, how do we create those containers that they're already cloud native ready? How do we create containers and start developing in those containers? And knowing that when your fellow colleagues and developers are developing, they're also developing in that container or a similar container environment. And local environment settings such as your Java, maybe your Maven levels, your framework levels, that maybe would traditionally be on your local desktop, are actually all running in a container locally, replicating those containers that actually at some point your CI/CD is going to deploy and put into your development and production, into production. And as I said, also looking to how do we reduce that complexity, or at least maybe that initial learning curve for people who want to start playing with containers, but don't actually want to learn all of the aspects up front. So again, just to recap some of those benefits, you're not developing, you're using your local code environment. Local changes are not going to affect your application, different to your CI/CD and production. All your development team should, regardless of which editor they're using, be all working against the same code base with the same inner-loop feedback and capabilities. One of the things we're looking to do as well is when you create your application, you move into that inner-loop space where you start actually providing your business logic. When you hit save, we'll automatically start moving that code into your local Docker container. Even though you get all the features you'd expect from your editor and the look and feel that it's local, actually that code is not installed. Your dependencies are not there on your local machine. They're actually in the container itself running on your local machine. How many people have had it worked on my machine when hitting problems and people come back and looking? Well, again, that's what we're really trying to make a thing of the past, because everyone will be working in the same containerized environment. So what do we have today? So today we have local IDE support using Docker Desktop. So all you need to do, Docker Desktop is a prereq install, go to your favorite marketplace and go and pull down Eclipse Codewind. We'll pull in a plugin into your environment and start building your containers quickly and effectively. Today, we support Eclipse IDE and also VS Code, which I guess a few of you from Steve's hands was a lot of IntelliJ. Well, the good news is this week we've just released a tech preview for IntelliJ as well. So it's I will give it a quick demo, hopefully as part of today, if the demo gods survive. It's not fully functional comparable to the other editors today, but hopefully within about a month we should have the same capability available for IntelliJ as well. So please go and take a look. Steve also mentioned, how's development going? So we're providing Eclipse Codewind. It's to help you develop containerization on your local desktop. But actually, what if you're already in a fully hosted environment where actually all your containers and development is actually in a remote Kubernetes environment or even running in a public cloud? Well, you can use the IntelliJ project. Is anybody aware or using the IntelliJ browser today? Good. If you haven't been over to the Eclipse booth, please pop on by and have a word with the people there from the IntelliJ. So IntelliJ is providing something that's very similar to the maybe VS Code experience, but all from within your browser with that editor running in your Kubernetes cluster, or be that in a hybrid environment, in your local environment, or be it on a public cloud, with all the sort of features you'd commonly expect. But what CodeWin does, again, when running in that environment as a plugin, will allow you to have the same experience you get local. How do I create a container? How do I start building my application in a container that reflects my ultimate production environment? And then the next thing we also provide is, as Steve mentioned as well, what if I kind of don't want to leave all my development behind? I don't want to go fully into a cloud environment. I still want to have that look and feel of using my favorite editor, but actually, I can run probably 1 or 2, maybe 3 microservices local and container on even a reasonably powerful laptop. But eventually the fan's going to start going, things are going to start heating up. So what if I can actually just take my remote cluster and actually have all my applications, my containers being built, executed, run in line with my inner loop, but actually it still feels to me like everything is running within my local IDE. To make all this happen, when you install Eclipse CodeWin, you get the plugin itself. When you create a new application, we have templates, and we have templates for a lot of the popular languages. So how many people are using Spring Boot here in the room? Yeah, I thought of quite a few. Microprofile? Okay, not so many. But also Node.js Express. What we allow you to do is create template applications from a template repository. Typically, we have default ones in GitHub, but you can build your own repositories with your own languages or your own tooling requirements. All of which, when you create an application using those templates, you'll get a standard framework pulled down, running in a local container for you automatically without having to do any Docker commands yourself, and we'll start the application running based on that sample application from the start. Then allowing you to immediately start editing your code in your editor. Every time you look to save an application, those changes will automatically get moved into your container and rebuilt. So none of it running locally on your local environment, all happening within the container. So let me just quickly show that again. So we have the local editor, new project, create, pulls a template file in from a repository. CodeWin will immediately take that template file, what it's got locally, start building a container for you in your environment, be that local, or if you're configured in your remote cluster, with that what would be initial, maybe a Spring Boot application running in there. Once that's created, it'll start pulling out any dependencies you have. So if you want, obviously, be using Maven, then the Maven repositories will be configured there. If you're using Node.js, it'll start pulling modules and from npm.js.org. And once you're running, you get into your iterative loop. You start providing your code. As soon as you hit save, the whole process starts again. Take those changes, automatically pull those updates into your container. So you can get an immediate feedback, again, without having to go to the command line, without having to modify your local Docker file, without having to go to the kube control command line to start pushing it into your containers. So let's see if the demo gods will be favorable. Sorry about that, that's a quick technical interlude. So here I have Eclipse running on my public cloud. As you see, it's all running within my browser. Has very much a VS Code look and feel. All my code here is actually running in a container in the cloud. And what I have with Microclimate is the ability to open a plugin, create myself a new application. So in this instance, I'm going to create we have a list of templates. These templates are the templates I described that exist in my GitHub repo. These are the defaults we provide as a project but obviously if you are working in your own enterprise, you might have your own definitions of what containers you want to use, what tooling you might want to put in there. As we have a good Swift contingency, I will create a simple Swift application. Give it a name, my Swift app.
Oh, yeah.
And immediately, CodeWin will go away, start pulling those template reference doing, and in my Kubernetes cluster, in my public cloud, create me an instance of that application running. From a IDE perspective, everything should look fairly familiar. So in my taskbar at the side, I can now see my Swift application.
You have 8 minutes.
Sorry. Have my Swift application, and I can see the source code that my template application gave me. I can see on the right-hand side here that the application is currently in a building state. That's because at this point, it's pulling down the base containers. It's starting to pull down the dependencies, things like Maven and Swift, Spring Boot itself. In this instance, it's probably going to take a few minutes because we're probably reliant on the public network and those Docker containers are being built. So what I'll do instead is drop to IntelliJ and show the same thing local. With the plugin already installed, I can create a new project. Immediately, we have the CodeWin plugin available as we pre-installed. I have my list of applications. We have Spring Boot, and I want to call it my Spring Boot app, my Spring app. Hit enter. We're doing the same here now. We're starting to pull down the templates, build the Docker images. But because I'm using local Docker, I've already pre-installed and cached the containers. So it should be a little bit quicker than starting afresh in the cloud. We can see here on the side, we have the CodeWin toolbar, much like the same experience that we saw when it was hosted within the Che environment. Why have I not got an add new project? The demo gods are not playing with me today. So if all was working, I would see the project, it would build, and we would then have the ability to show that if you saved the application, did a refresh, all those changes would be reflected in the local container.
Well, okay. I think we're going to stop because we're just digging a hole. I encourage you to have a look. It is really cool, and it is first steps. We're trying to give you, we're giving you the same development experience that you have in your IntelliJ environment, and we're trying to help you connect it to your cluster. Okay. Can you just bring up? Sorry. Okay. So some takeaways. We're at the beginning. If you have done any debugging with containers, you probably ended up trying to SSH into it, and that's just horrible. So we're better than that. We're definitely better than that, but we're still at the beginning of the journey. We're not trying to take your laptop away. We're not, because people go, I can't do it with the laptop. You still get to do all that. What we're trying to do is bring the smarts into your IDE that you need to interrupt with your cluster in a way that means it's the same experience at all these places. It's beginnings, but you saw Eclipse CodeWin is a good example. Eclipse Che is everything running in the cloud, different view of life that. But if you go look at the IDE guys, you could IntelliJ and stuff like that, you will see more of this, right? So most of this talk was to say, be prepared for a different life than you've had before, and quite possibly be prepared to have a developing experience where you can't work offline, because it's becoming harder and harder for us to justify putting effort to give you an environment locally that means you can do that versus taking you to the cloud. That's it. Sorry, thank you very much.